Hello, everyone. Hope you've been having a pretty informative, enlightening afternoon, discovering all what you can build on Polkadot. The last panel to me was particularly fascinating as we talked about what the next evolution of dApps look like. I want to continue that conversation by talking about a certain point in your decision-making process. When you get to the moment of thinking about maybe it's time to take my dApp into a blockchain, into its own proper parachain, and sort of the considerations to think about when you're at that moment. So let's start by first a premise. That as a dApp creator, as a dApp builder, you are creating something absolutely incredible. And I'm not just saying that, but let's say you're building a dApp and time after time, month after month, you are getting new traction, new users, more transactions. You are filling some need. Or you're building something really fun. Either it's really fun or you're building something that really solves a need. Either way, you are gaining more traction over time, which is awesome. And you should be happy about that. And perhaps you're building it with this cute little squid. Does anyone recognize this squid? This squid, of course, is the mascot for Ink, which is the smart contract language from Polkadot. It allows you to build your smart contracts using Rust, with all of its type safety, its concurrency. You come to love the compiler. First you fight with the compiler. First you feel a bit of an inferiority complex with the compiler, but then you eventually come to love the compiler, and your Rust smart contract code gets compiled to WASM, and you can upload that WASM blob to any smart contract chain or general chain of your choice and put your contracts right there. So you're building your dApp with Ink. You have, using the beauty of the type safety and the concurrency of Rust, you compile it to WASM, and it's on the chain, and it's gaining users. Your dApp is really successful, but perhaps it's just a bit too successful. Now, that may seem a bit counterintuitive. How could it be that your dApp gets too successful? But one example of what that means is you're growing, you're gaining more users, there's more transactions, and as a result of that, you're watching just one example, you're watching your gas fees rise, right? And you are trying to build something here, some kind of economic model to make this dApp sustainable. And suddenly your gas fees keep going up and up as you're gaining more traction, and it's even getting hard to predict exactly what your gas fees are. So that's just one example of sort of where you encounter the limitations of being a smart contract, being a dApp as a smart contract on someone else's chain. There's other examples, but that's one moment. And if you're at that place, you're probably somewhere in this dialectical tension between technical freedom on one hand and development ease on the other hand. So on the perspective of technical freedom, well, that's of course Polkadot with a parachain with a lease on Polkadot, right? But on the other hand, with development ease, is really when you get out to pushing to production your dApp as a smart contract using Ink. Because you can write quickly, you only need to worry and concern yourself with the application layer of the code, and you can build exactly what you need, and Ink helps you get done and expedite the process. You push it out, you start building users, but you suddenly get to the point where you're facing limitations. Perhaps you're facing limitations around governance, perhaps some issues around token, maybe some scalability issues, and that's when you start this conversation of migrating. Your brain is starting to think about maybe the time is right to go a bit deeper in this process and take yourself into that parachain conversation. And as you build a parachain, well, you're building an entire chain, right? So you get the freedom to customize it exactly as you need it. But with the freedom of customization, concurrently comes more technical complexity, right? The more customization, the more complex the decision-making needs to be, because you're no longer concerned with just the application layer. Now you need to concern yourself end-to-end with all the decisions for the chain, with user identity, with security issues, with weighting of functions, all consensus mechanisms, all sorts of things you need to start being thoughtful about as you start building this out, but you get that customization. So when your Dapp is a smart contract, well, you're quicker to develop and to launch, but you're basically code on someone else's chain, right? So you're encountering scalability issues. It's resource intensive. The state transition logic is defined for you. What happens if you need to start instituting some kind of governance model? Well, you are on someone else's chain. Do you see the theme we're getting here, right? When you are in code on someone else's chain, that is wonderful and works well until it doesn't. And when it doesn't, that's when you need to start thinking about being a Dapp as your own parachain. Well, because you're your own runtime at that point. You're no longer a layer on top. You have the speed of your own runtime, your state transition logic. Well, you get to define it yourself. There's no more gas fees, so your costs are more predictable, which means you can understand and build out economic models. Based on that, it helps you grow your users, helps you grow and continue to grow sustainably. You get the benefit of forkless upgrades as being part of the relay chain, as Sean spoke about, and you get to define your own transaction fees. Maybe you want to be totally wild and have no transaction fees, but whatever you want to do, whatever makes sense for your purposes, you get to do that. And of course, as we mentioned, you can also create a token for governance reasons, maybe utility reasons, maybe it's a DeFi purpose, whatever you need it for, you now have the flexibility to do that, which is all well and good. But before we continue going forward, I want to just take one moment, because I've said a word several times, and I want to make sure we all understand this word and have a shared definition to move forward before we start talking about, at a high level, how you go from a Dapp to a parachain, which is, what is a parachain, right? I've said that word several times. Sean gave a brilliant presentation in the first slot in the morning, going through all of the philosophies of Polkadot and the parachain and decision-making process. But if you weren't here for that, or you want a quick encapsulation, what essentially is a parachain? So to understand what a parachain is, we need to understand what Polkadot is. These are a lot of really big words. I will define and break down these words. Polkadot, these are huge English words, right? Polkadot is a heterogeneous multi-chain protocol that connects and secures blockchains with pooled security and interoperability. What that means is Polkadot is a diverse multi-chain protocol. It is a chain that encompasses unique chains fulfilling all kinds of specific use cases. It does not believe in the idea of one chain to rule them all, but rather a universe where people build chains that serve different purposes and yet come together to have pooled security and interoperability, which means that they can essentially talk to each other. You have a unique chain that does A, you have a unique chain that does B, and with interoperability, we can actually share assets, we can even share code. We can share messages from chain A to chain B. So having said that, if you want a quick visualization of what that looks like, so in the middle there is your Polkadot relay chain, and around it is all of what we call the parachains, which are independent blockchains that have slots on the relay chain. Each parachain can be built with Substrate. Who's heard of Substrate? Who's used Substrate? Amazing. Okay, so Substrate, you know, is the SDK to build blockchains from Polkadot. It is like Ink is the smart contract language. Substrate is the SDK. You can build a parachain without Substrate. Did you know that? You can build a parachain without Substrate. I recently did that experiment at the Polkadot Blockchain Academy. I would not recommend it It is a very painful experience, but you could do it. But why would you do that? But you could torture yourself if you want to. But Substrate helps abstract a lot of the complexity for you, helps, just like ink helps you get your application out in a more faster way to ship to production, so too Substrate lets you get your chain out faster to ship to production quicker, expedites the process for you. So, and in a sense then, we come to understand that a parachain is basically an independent blockchain, right? It is a blockchain that lives on the relay chain for interoperability, scalability, and security. Now that we have that shared definition, we can then have a bit of a conversation on how we go from a Dapp to a parachain. What does that process look like? And there are caveats. There are many lenses to what that process looks like. There are many views one could have to talk about the auction process, talk about sort of what it looks like from a business perspective. We're going to look at it very briefly from what it looks like from the code perspective, going from, let's say, ink, going to Substrate, what you need to think about and what that might look like. So to go from a Dapp to a parachain, in our context, what we are going to talk about is going from ink to Substrate. You started building out your Dapp as a smart contract using ink, and now you're ready because of gas fees or governance you want to introduce, or scalability issues, or customized state transition logic, or what have you. You are now ready to go to the parachain. So you have a few benefits coming into that picture, a few head starts. One, ink and Substrate are both built with Rust. And when you're already in one language ecosystem, it's quite nice to not need to jump to an entirely new ecosystem of developer tooling. You've already come to understand the borrow checker. Don't let all of that pain of understanding the borrow checker and lifetimes go to waste. Use it and continue using it as you build into Substrate. Now, it's not just that, you also get shared primitives, right? So between ink and Substrate, they use the exact same primitive types for important things like the balance and block number and other primitives. So your mental modeling of your application, of your Dapp, continues the same from ink to Substrate. And similarly, encoding and decoding of data is done with scale, both in ink and also in Substrate. So these things are not to be understated. They are very helpful when you're transitioning from a smart contract, from a Dapp, into a proper parachain. You get to start already in a bit of a head start. You don't have to start from zero. You already have a bit of a leg up. What that looks like in practice. So here's a sample, very simplified smart contract example using ink. And what you see is a smart contract that does one thing. What is the one thing it does? It flips a value. So you have a storage struct containing a Boolean value of, let's say it starts instantiation of the contract with a value of true. You would invoke the flip function and it would turn true into false. And if you did it again, it would turn it into true. Amazing. So this is brilliant. You see some attribute macros for ink storage and ink constructor and ink message. And what all those are doing is putting tons of code around your code, things that you don't need to worry about as you're building the application and does it for you. And you can build the logic for your application and focus on what matters. You can build this exact same thing as a parachain using Substrate. And the code will look different though, right? Because unlike ink, Substrate is worried about and concerned with end-to-end the whole blockchain, right? Ink is concerned with the application layer. But when you're building a parachain, you need to think of the whole picture from one end to the other end. So the way this looks like in Substrate, well, there's a bit more code, right? But I want to focus in on three parts of it, and it's not important to see every detail, but three important parts which will show you the connectivity between ink to Substrate. One, of course, is you get to define the storage. So instead of the attribute macro of ink storage, you have palette storage. You define the storage struct. And then the second thing is what we call the Genesis config and Genesis build, which is the instantiation, the first block on the chain. So just like you build and define what the instantiation of the smart contract will look like, you get to define what the instantiation of your blockchain will look like. What will be the data on the first block that's produced on that chain? So in our context, in the smart contract, what is it instantiated with? A Boolean equaling true. true. In this one, what is the first block instantiated with? A Boolean equaling false. And similarly, just like you have inc message, palette call, you can define the functions that you can invoke on your chain, and this function is absolutely the exact same function as the flip function in inc. It reverses the value, it mutates the value to be the opposite of what it was to be now that opposite. So from false to true and true to false. Now you probably built as a Dapp something a bit more complex than changing a Boolean value. But no matter how complex it is, no matter what your Dapp's use case is, whether it's a game or something else, it doesn't matter. You can actually convert that using the same primitives, using the same language, using the same scale for encoding and decoding into a parachain. I want to end with a bit of a sneak preview, and this has been mentioned a couple times, and I think this is actually incredibly exciting. This sneak preview, of course, is called Parathreads. Who's heard of Parathreads? Parathreads, woo! Parathreads are amazing. The idea of a parathread is absolutely amazing. So if you heard about it, you already know what I'm talking about. But essentially what a parathread is if you look at this diagram of sort of the Polkadot ecosystem, in the occupying sort of the bottom part of that is the relay chain, and you see different parachains on parachain slots, but then you see something really different, this thing called a parathread pool. What is a parathread pool? Well, to understand what a parathread pool is, we need to understand what problem it is coming to solve. Parathreads are coming to solve the following two-pronged problem. So you're moving from a Dapp to a parachain because, let's say, the gas fees are getting really out of control. But you're not yet at the stage where maybe you can afford or go through the complex process of going through an auction for a parachain. Right? That's a sometimes expensive process, crowd loans. Maybe you're not at that point yet, but you're definitely past the point where you can continue to afford the fees of your smart contract. And secondly, maybe you're gaining users, you're gaining transactions time after time, month after month, but you're producing blocks, let's say once every few hours, or once an hour, or whatever. You're not producing blocks every 6 seconds, every 7 seconds. And we know that an auction on a parachain is dedicated block space for you, right? And how much or how little you use it doesn't really matter. It's your block space dedicated, but if you're underutilizing that block space, it's kind of a shame, right? So these two problems are answered by parathreads, which are pay-as-you-go parachains. They are in every shape, in every way, in every form. They are a parachain, but instead of paying for dedicated block space, you pay for what you use. And I see this, and I think this is exactly the way to see it, as a fantastic incremental step from your smart contract Dapp to your proper auction, dedicated block space parachain that you are growing, you are continuing to build, continuing to gain users, continuing to gain traction. Let me go to that pay-as-you-go model, and if I continue, hopefully getting more successful, I will then go through the process of getting dedicated block space. So to conclude, to put it all together, we've talked about a few different things in a very short period of time. Putting it all together, essentially 3 things I want you to remember. If you don't remember anything else, remember these 3 things. You ready for the 3 things? Okay. First of all, inc to substrate. Right, going from a Dapp written with inc to substrate to a parachain written with substrate. You have Rust, you have shared primitives, and the same encoding and decoding of data with scale. Remember those things. They're important. You're going to get tested later. Remember those 3 things. Secondly, what is a parachain? We've used that word all the time. It is an independent blockchain that connects to Polkadot for shared security, scalability, and interoperability. And lastly, what I'm really excited about is what's coming soon, Parathreads, where it is pay-as-you-go blockchain space, pay-as-you-go parachains that allow you to incrementally build from the next step from a Dapp into a parachain. Thank you very much. It was a pleasure.